Hi, everyone. I'm Catalina Garza, and my other co-presenter is Chad Cerutti. We are the Bioastronautics and Life Support Systems team here at the University of Michigan. We work directly with NASA to develop technologies for astronauts and future space missions. The past couple years, we have been working on user interfaces for astronauts, allowing them to control a space station using new technologies like iPads, smartwatches, instead of using buttons and switches like they previously have. We're excited to share this year's research into our voice-activated user interfaces. So our goal from NASA was to design a unique, efficient, and intuitive voice management system for autonomous operations aboard the Lunar Gateway for crew interactions. That's a mouthful, but essentially it means that they wanted us to develop a system like Amazon Alexa or Google Home with a few key differences so that the astronauts can use it to control space station. We wanted our voice user interface, or VUI, as we call it, to act more like a human rather than a robot assistant. To accomplish this, the system needed to be able to understand how a human might ask the same thing in different ways. And then at the same time, to make it more human-like, they needed to be able to respond quickly and add character into their responses. And then to supplement our overall system, we created graphical user interfaces on a computer screen for accessibility purposes. We wanted to also research background noise mitigation that we would need. As you might know, that the ISS is really noisy, and so we expect the gateway to be very similar. So here is our concept of operations. Our VUI, who we named Diego, begins with the astronaut stating a command, as in, hey Diego, what's the temperature? This is heard by the microphones, and then converted to a string to speech to text engine, then deciphered by our natural language processors to figure out what the what the user actually intends. The natural language processing then pulls up the appropriate data from NASA's autonomous system and reads it out to the user. Each step in this process, from the way the user asks to a question to how the user understands or acts on the question, is vital to our project, and we'll explain further. So one of our major sub-teams was conversation design. The top priority was to design a system with an enjoyable personality. We wanted the user to be comfortable assessing the system and be able to build a level of trust with it. To accomplish this, we researched the various traits a voice assistant should have and came up with the ideas of a person that might fit them. We eventually landed on Diego, a 39-year-old male from Spain with multiple STEM degrees who loves his family and outdoors. There we have like Diego's personality. We built it by surveying students, faculty, and industry professionals. That's kind of how we determined what Diego should be like. And then we made those traits into his personality, and that's kind of how we built off of it. So there are 4 components that we wanted Diego to focus on. This was station vitals. This is asking like what the temperature is, communication with other crew members and to ground, scheduling. So if an astronaut wants to do something at a particular time, Diego would be able to help with that. Tasks. So when an astronaut is doing a task and they might need instructions, Diego can help guide the astronaut through this process. But all the conversations the user starts the conversation, the system responds, and then the user asks whatever they may need, and the system verifies it. And like making sure, like if somebody asks what the temperature is, Diego would ask, are you asking about the temperature? And then you would verify that's what you want, and then he would provide an answer. So on the right, we kind of have an outline of how this might look. And this is general for the station vitals. That's how they're structured. The communication, scheduling, tasks are a little more specific, but we're only going to present this one for time purposes.
There we go. Now I'm unmuted. And yeah, and so for the software team, it was our main priority was really taking what conversation design did and all their planning for Diego's conversations and giving Diego a brain and bringing him to life and really trying to give Diego as many capabilities and like the groundwork that we really needed for that. And really what we used for that mainly is an AI software called Rasa. It's able to fill in some of the gaps of user questions and then match it to the conversation paths that we showed you before. It really attempts to help understand the user's intent as best as possible so that Diego is accurate and quick and reliable, which is what we want in a voice assistant. But the system as a whole isn't just Rasa in understanding the user's intent. We have a wake word detector, a speech to text engine, as well as a supporting graphical user interface as well. And so this is our system as a whole, how it works, and I'll walk through it a little more in depth. So the user starts, they say, "Hey Diego," in a software called Porcupine by Pico Voice is a hot word detector. It'll only activate the system when you say the words, "Hey Diego," otherwise it'll keep the system sleeping. Once it hears the words, "Hey Diego," then it sends a message off to the Flask server, which is kind of the intermediary for all of these different pieces of software. And it sends a command to our speech to text engine to listen to the user. And so it's at that time that the user will state their command, such as "what is the temperature?" And the speech to text engine will take those sounds and turn it into a string. It'll then send that string through the Flask server over to Rasa, which is really where the brains of Diego happen. It takes the string of "what is the temperature" and figures out, okay, so the user wants to know the temperature. And by default, it wants to know the temperature they have, and it wants it in degrees Celsius and does a lot of backend work. And then from there, Rasa activates a command and integrates and works with NASA's autonomous system called NPASS to figure out, okay, what is the temperature at this time? And this is a very basic example because NASA's autonomous system obviously has more commands than just stating the temperature. But for our purposes, we wanted to keep things simple and allow NASA to kind of build on our groundwork. So it takes that information from the autonomous system, runs it back through to the Flask server to a text-to-speech engine, where Diego will then actually speak the temperature, say it's 27 degrees in the habitat right now. And then the user can understand that and then continue on with their mission. And so we have a demonstration video for it. We had a couple limitations. So for time purposes, we focused on station vitals. We didn't implement some of the other systems because Station Vitals most closely aligns with NASA's NPASS system and works with it, so it made sense to focus on it. And we also couldn't find a suitable male voice to use, so we went with a female voice instead. So for this demonstration purpose, it's not Diego, but it's Dora speaking. And so I'll show a video now for that.
Hey Diego.
How may I help you?
It's nice to meet you.
It is great meeting you.
Hey Diego.
How may I help you?
What is the temperature?
The temperature in the habitat module is 21.15 C.
Hey Diego.
How may I help you?
What is the pressure?
The pressure in the habitat module is 100.57 kPa. PA.
Hey Diego.
How may I help you?
What is the pressure in Pascal?
The pressure in the habitat module is 101.11 kPa.
Hey Diego.
How may I help you?
What is the pressure in Pascal?
The pressure in the habitat module is 101,110.0 Pascal.
Hey Diego.
How may I help you?
Goodbye.
See you later.
So as you can see, it's not the most intelligent system at this time, but really our main work was laying this groundwork for NASA, getting all these different pieces of software together and trying to integrate them into a working minimum viable product. And so at this time, the main improvements that you'd make are just adding more conversation paths and more pieces of information for Diego to recognize and a little bit of error managing. And we covered most of the complicated system integration part of it. So we're really happy with a lot of the work we did. NASA was extremely happy with it as well. So yeah, we're happy to pass that on to the team later. We don't need to do that again.
Okay, so I'm gonna talk a little bit about the graphical user interfaces that we made. These are meant to complement and support the VUI. Some of the key features we have are messaging, note-taking, schedule, carousel, task instructions, visual access, notification and menu pop-ups, and VUI command assistance from the home screen. So the functionalities, we have home screen, we have a screen for video calls, we have a messaging with a keyboard options, note-taking and personal logs, as well as a scheduling carousel and station vitals and notifications. Here's a little video about, a video about our GUI at the bottom. We also have a link so you can actually access the Adobe XD where we built all these. Although we weren't able to implement them, but we do have mock-ups to implement if the project went further.
Hey Diego, pull up the station's atmospheric conditions. Hey Diego, pull up the ISS malfunction checklist. Hey Diego, call Winnie. Hey Diego, what's on my agenda today?
I also just wanted to make a note that the reason Diego isn't responding is because this is on Adobe XD. This wasn't actually our final demo. I forgot to mention that. So this is kind of what we imagined it would look like in the future if we had the GUIs implemented.
Hey Diego, pull up the station's.
And then so finally, as we mentioned before, because we were taking this holistic approach to really bring a whole voice user interface system to a space station, we wanted to make sure that not only did we have a system in place, a voice user interface system, but that we'd actually be able to use it on board the station. So we did a lot of research into background noise and mitigation because, like we mentioned before, the space station is an extremely noisy environment currently, and we anticipate Gateway and future lunar habitats being the same. Just for reference, the Gateway system, the ISS can get up to about 70 decibels during the day, which is the equivalent of running a vacuum. And then for a voice activated system to work properly, you have to be 20 decibels above that, which would be about 90 decibels, which is about the sound of a lawnmower. And so if you can imagine someone screaming at the top of their lungs to be as loud as a lawnmower all day, it'd be extremely difficult for the system to use. So we looked into a lot of different mitigation strategies for that. The two ones focusing on were active noise control and passive noise control. And so as you can see, I'll explain passive noise control first. It's using different foam samples like you would see in a recording studio, and there's a photo of it on the right side, to block out some of the higher frequencies and just passively kind of reducing the overall noise in the station. And there's also active noise cancellation, ANC, which uses softwares and canceling sound waves to actively cancel out the different sound waves moving through the air and reduce it using more advanced technology. And so from our testing for the passive noise control, we wanted to try to get that 20 decibel reduction so that we could be speaking at the sound of a vacuum cleaner, which isn't ideal, but it's a lot more manageable than louder noises. And for our testing for passive, we were able to get that 20 decibel reduction at the higher frequencies pretty reliably. So we were very happy with that. And then for active noise control, we have a demo from one of our teammates, Owen, who displays some of the work that we did with an RTX to demonstrate active noise cancellation.
Hi, everyone. So this is going to be a demonstration of NVIDIA's RTX Voice, which is an active noise cancellation software built by NVIDIA. So what I'm going to do is I have this microphone here is set up with the software running. This microphone is just a standard mic with no software running on it. And next to me, I have like a standard house vacuum. So what I'm going to do is I'm going to turn the vacuum on, talk into this microphone, and I'm going to switch microphones so you can hear the difference between what's going on in the room and what the software is able to distill. So I'm going to go ahead and fire up the vacuum. You should hear maybe a little bit of background noise from it, but for the most part, you should still be able to hear me. Now what I'm going to do is switch microphones, and you should be able to hear a lot more of the vacuum. So I'm going to go ahead and switch over right now. I'm going to keep talking. I don't know if you'll be able to hear this because the vacuum is quite loud, but you should be able to tell that there's a lot more background noise going on. Now I'm going to switch back over to our original microphone, which is running the software.
And so as you can see from that demo in the beginning there, with RTX enabled, combined with the passive noise cancellation, we get a very strong reduction in the overall noise for the system that we're very confident that a voice user interface system could be implemented on the space station or on any space habitats if they implement active and passive noise cancellation. And so just to summarize what we've done this year, we took a holistic approach to creating a voice user interface to be used on Lunar Gateway, and then also use it as groundwork for future space missions. We divided the work into 4 different subgroups to accomplish this. We had the conversation design team, which created Diego, gave him a personality, and figured out how a user would converse with Diego and how Diego should respond. We also had the software integration team that gave Diego his brains, helped make sure that the user could speak to the system and it would respond and connect with NASA's system. We also had a graphical user interface team that really focused on accessibility and supplementing the voice system, adding some capabilities that you just simply can't do effectively with the voice system alone, and really trying to work in tandem with those two. And then finally, we had the background noise mitigation team to make sure that our work was not for nothing and that we could effectively reduce the current noise levels on the space station to more acceptable levels. So there's our key takeaways. Thank you guys for listening. This is the work that we did this year. I do want to touch on, so we're a team that works every single year with CEDS. We propose to NASA on different technologies. Next year, we'll hopefully be working on space habitation in space. We'll know more information about that ourselves in the coming months. But we're really thankful for CEDS, who's been with us for the last 5 or 6 years, and really excited to share the work that we've done for the last 2 with NASA.
Great. Thank you all so much. That was very entertaining. We were joking a little bit that we're going to need some of that background noise cancellation soon. We had some serious thunder here in Ann Arbor going on. So yeah, that was awesome. It was a really cool demo.
Yeah, no, our plan is
so
to hopefully we're going to, I was going to say we're going to try to take that background noise mitigation and just keep it in the lab permanently, because there's a lot of really loud fans and noises going on there. We'll try to help reduce that too.
That's great. For when you're using the meeting setup in there.
Yeah, exactly.
Yeah. So we've got about 7 minutes left until our next talk. So if anybody has any questions, feel free to send that into the chat. I also wanted to let everybody know that we'll be making the slides available. So if you want to rewatch any of those videos, or if you want to click on the link to their Figma, that will all be available in probably a little less than a week. So. You have any questions? Start us off.
I really don't. I usually do.
You guys are very thorough. I guess, so what teams at NASA have you mainly been working on, in case people are interested in learning more about those?
Yeah,
we've been working with the NASA group for autonomous systems platform. They're based out of Stennis. We've been working with them for the last 2 years, and we were really grateful to have them as our affiliates. They're really responsive, and they support us in everything we've done.
Great. Very cool. Are they going to be taking over this work then next year as you're transitioning into a new project?
We're not sure right now. I think they're still working mainly on the autonomous systems that they can build on the gateway. They actually had not had any development with voice user interfaces, so we worked on this before they did, and we had our final review with them yesterday, and they're encouraging us to publish this paper because there is nothing like it out there currently. So we are in works with them this summer to do that.
Absolutely. That's great.
Yeah, we had some pretty heavy collaboration too on the interfacing between our project and their autonomous system too. So that directly we know will be like used right off the bat, and they were developing it for themselves to use. And we're hoping that a lot of the groundwork that we've laid and stuff will be carried over as well to the team.
Right. Yeah,
Nice.
it's very different. You don't often think about Alexa for space, so
Yeah.
I think that's great.
Yeah, we initially were even thinking of using it for like when astronauts are on an EVA. It might be extremely useful for that as well, because their hands are tied up outside the space station, and being able to query information with an autonomous system and figure things out would be extremely useful for that situation as well.
I'm curious, did you all consider, like, for your name for your assistant, what if there's a astronaut named Diego? And then any
They would
Not-
just have to deal with it, I guess.
the astronaut needs to go by a different name.
Yeah, no, the assistant has to keep his name for sure. He's priority number one.
They could call the
Nice.
astronaut Diego number 2.
There you go. He's number 2. Yeah.
Yeah, I have a question. So, what is the testing process like for conversational AI? And then how have you done with everything being remote? Like, who is doing the testing? Is it internal? What's that look like?
The software testing you're talking about, or figuring out the conversations? I'm not 100% positive. I don't think he's on. But so through RASA, they have a very robust kind of built-in testing and training program for it. So the conversation design team essentially just writes up different words or different phrases that have a, and then, yeah, you pick out like phrases and then write in whatever their intent is. And then you basically just feed that base information into RASA, and it helps train the system based off of that. And they try to pick out like the keywords and then match it. It's a lot of behind the scenes stuff that we didn't have to even do on our own because it just kind of worked into RASA. But
Right. Nice. And NASA's allowed to use something like that? The software?
yeah, it's open source code. So
Sweet.
yeah, that was one of the main focuses in this software, like picking out stage. We originally wanted to use like Microsoft or Google's kind of API for speech to text and things like that, but it has to be offline and it has to be open source. So we had to go through and make sure that every like piece of software we used was something that NASA could adopt as well.
All right. Well, thank you all so much. I don't think there's going to be any questions right now, but if anybody has questions, feel free to direct it to them in the chat. Thank you so much, BLiSS, for coming. It was great to see your progress, and I'm glad that your final review went well.